Lastly, we studied the limit cycles, something that is appropriate only for nonlinear systems. Now, let's study the bifurcations, and this is also appropriate only for nonlinear systems. Let's start with this equation, the differential equation of the first order. And let's think about the parameter r. Let's assume that this parameter can be changed. It can have different values. And we are interested in two cases when r is negative and r is positive. We can define the equilibrium points. So let's do it in the same way as we did before, but our system now is the system of the first order. So we take our right hand side and equalize it to 0, and our final expression for defining the equilibrium is the following: x squared equals minus r. In the case when our r is negative, we will have two equilibrium points. X star is our notation for that. So let's denote this is the first point and this is the second equilibrium. In the case when r is positive, there is no equilibrium. Let's continue. Let's linearize our system. So our linearized system will have this structure where a is some scalar. And we use the same formula as we did before, but a is not a matrix, but some scalar. Finally, our a is equal to 2x star, and for x star we'll substitute the values square root of r or minus square root of r. We will have the following cases. So we can define parameter a in both expressions. And we know from the beginning that system is stable if a is negative and unstable when a is positive. So square root of r is always positive, so we can determine the cases. For the first point, the system will be unstable, and for the second point, the system will be stable. Let's summarize what we have done recently. In the case when our r is negative, we have two equilibrium points, or two equilibria. In the case when our r is positive, let's solve the following example. Build a bifurcation diagram for the given system. Let's equalize our right hand side to 0. And we have the expression for defining the parameter r. If R is negative, then we have no equilibrium. If our R is positive, then we can have two equilibrium. First is square root of R, and the second is minus square root of R. Let's linearize our system. We need to take the derivative with respect to x, and this is just minus 2 and x, and now substitute x star, so minus 2x star, so this is the parameter a. So our system will behave like the following: minus 2x star times x. So this is the parameter a. And now we are ready for expressing everything on the diagram. So vertical axis is responsible for the equilibrium points and horizontal for the parameter r. When our x star is positive root of r, then our a will be negative. So we can draw our upper branch as a solid line and label it as stable. If our x star is negative root of r, then our a becomes positive. And in this case, we understand that our system is unstable, so we can use this dashed line and label it as unstable. So now our diagram is ready, and let's add that r equals 0. This is our bifurcation point.